Hello, my name is Sandeep Pawar. Welcome to my session on breaking data silos with Semantic Link. A little bit about myself before we get into the topic here. I'm a senior Power BI architect at Hitachi Solutions. We are a Microsoft Gold partner and we work with all the entire Microsoft data stack. Also a Microsoft Data Platform MVP, and I write blogs at fabric.guru, especially focused on Microsoft Fabric and how Microsoft Fabric can be used to create data analytics solutions, be it data engineering, business intelligence, or data science, using Microsoft Fabric platform in your organization. My experience is in data analytics, data science, and data engineering. Before we get into what is Semantic Link, what is Microsoft Fabric, and how it all comes together, I want to just first discuss the motivation. Now, I have been doing data analytics and I've been in data science industry for the past 15 years, and I have played roles as on the business intelligence teams, on data analytics teams, as well as data science team. My background is in research, so I actually started with data science. But as I straddled these different teams and different positions, one thing that was very common among all of these different teams was these teams operate in their own silos. And what I mean by that is a let's take an example of a data science team. Typically, the data science team is very focused on it's a very code first approach. They get their hands on the data, they work with the data using Python or R or any language of their choice, and then create solutions and then deploy them. Whereas on the other hand, the data engineers, very SQL focused, their job as they see it is mostly to provide the data to the data science team and as well as to the business intelligence team. And they are a little bit removed from the actual application or the actual final result or the predictions that are created by the data science team. On the other end of the spectrum is the business intelligence team, which typically works with the data engineering team to get the data. Goes through the medallion architecture, which is the schematic that I'm showing here on my screen, where the data lands in the bronze zone, you cleanse the data, and then it is converted into a dimensional form in the gold zone. And the data science team either uses the data from the gold or silver or from somewhere else and then create the data science solution. And the business intelligence team, typically using Power BI if you're using the Microsoft data stack to create the reports. Now, the challenge with this is although they on paper work as a team and they use the same data, after the solutions are created, because they use different tools and technologies, there is a gap in the communication. And what I mean by that is, let's say, for example, the data science team, they create some forecasting prediction algorithm or prediction model, and they deploy their solution. The Power BI, the business intelligence developer, he or she, they're going to use that into their report. But the challenge in this case is the BI person, the BI developer, they don't necessarily know how the model was created. Now, as you know, uh, a machine learning model is probabilistic in nature. It has assumptions underneath, be it the data generation assumptions, be it how the features were created using different data types or different data. Maybe it was augmented using different data, and the BI developer is not going to know that. And it's very much possible that their definition of the forecast is completely different from how the assumptions were made by the machine learning engineer or the data scientist. So that's problem number one. Number two is the difference in languages, meaning the BI developer typically they won't use a Python or R. So even if they are using the languages, it's going to be hard for them to actually understand or to figure out how these different features or how these different business definitions are created and what they mean. So again, taking an example of, let's say, forecast. The forecast is going to be created based on, let's say, sales. How the sales are calculated. If you worked with business intelligence, you know that there might be some definitions created. For example, exclude internal accounts, exclude internal customers, take only certain product types into account and exclude R&D from it, so on and so forth. And all these different definitions which capture the business logic are embedded into how the net sales is calculated. Now, when you use the business intelligence person is going to use these definitions, they assume that the data scientist may have used the exact same business logic and business definitions as well. Even if they do, because the difference in technologies, all these different technologies that are used, for example, the data scientist could be using Databricks or Data Robot or something else, whereas the business intelligence developer will be using Power BI. So they don't necessarily have the same tools and the technologies or access to the same tools and technologies, which can create a miscommunication or the data silo. uh, Definition drift, and again, something, for example, even if they do know and have access, and let's say they use the exact same definition of what accounts for or what you mean by net sales. You work on a project, you move away from the project, and 6 months from now, maybe the business requirements have changed, and there's a new data scientist and new business intelligence developer, and they don't necessarily know that how these definitions were created. So they could create their own definitions again. So there is no way to really reconcile that in on any platform. They could change their definitions, and so if that happens, then the predictions that have been created by the data scientists could be off and no longer valid. Reusability of these definitions and KPIs and the features, meaning each of them are going to use or are going to create net sales. So why should they create this definition of how the net sales is created on different platforms for single source of truth, and to make sure that the business users who are going to use this data or these solutions to make business decisions, they should not have to figure out how each of these different teams are aligned or not, right? So if ideally what we want is these definitions are created in one single place and then used throughout the entire life cycle of the project in different stages and different applications and different platforms, without worrying if the definitions have drifted from each other. And then using and creating data science solutions. Meaning for many organizations, the data science is still something that's looked as uh, you have to hire a PhD and a PhD person and then create these data science solutions, which is far from truth. We want data science solutions to be more accessible even to small organizations who may not have the technical know-how to do that. So which means a business intelligence developer, for example, they should be able to create these data science solution in their organizations. And it's not that you just get up and then create these data science solutions, right? Typically in most organizations, just based on my experience, the way it happens is you create a report, and then the business users, they use those reports, and then they notice something, and then that generates a requirement. Okay, we need to have some predictive ability, and that's how you generate, or maybe more insights, and that's how you generate a data science solution. And Microsoft Fabric offers us a platform to unify all of these requirements on one single platform. It's a SaaS platform where you use different compute engines on the same set of data or same data and just use different computes. Meaning we can use data science notebooks and then Power BI, which is business intelligence, on same data, and all of these different persona, they have access to the same data and all access to all the solutions that are created. So which helps us break these silos. But going beyond that, it's not enough to just have a platform. There are many platforms that allow you to have, all create all these different solutions using one single platform. Where Fabric differs is you can use what's called as Semantic Link, which is a Python library you can use to access both to create a collaboration between BI persona as well as the data scientist. And what I mean by semantic is if you're coming from a data science world, just a bit of clarification here. A semantic model is nothing but data with some business logic on top of that, with human concepts and links and relationships. So what I mean by that is typically in a data science project, you have the data, you have the business data, that's one flat table. But in the business intelligence world, you define on top of that some definition, the business logic. So again, take an example of net sales. The business logic there is it's not just sum of a column called sales. You apply some business logic to it, meaning you filter a few things out, you do some transformation on top of that, and then plus you add some human concepts to that. These human concepts are something that are used within your organization, something that's very well known within your organization. And then you create relationships like enterprise relationship diagrams, if you're coming from the database world, then to create these relationships on how different data sources are related to each other. So let's get into it. So what I've done here is I already have, if you're new to Microsoft Fabric, as I said, there are all these different compute engines. These are tied together on one single platform. So I went to this persona switcher, and you can see I have Power BI, which is used for business intelligence, data engineering, which you can use Spark and Spark SQL and T-SQL to create data engineering solutions. And then we have data science, which includes notebooks as well as creating machine learning models and deploying those machine learning models. And then MLflow is integrated into this whole platform. So you can create machine learning models, experiments, and then be show those or share those with your business intelligence and data engineering counterparts as well. I can go to data science and then create a notebook from here, but I've already started a notebook which I want to show. So the first things first, what we need to do to use Semantic Link is to install Semantic Link, which is pip install Semantic Link. And this is only available in Microsoft Fabric. So this won't work in outside of Microsoft Fabric. You only can use it in Fabric here. So once I have installed this, I can import it into I can import it into my notebook as SemPy, which is semantic, sem for semantic, and then py for Python. So import sempy.fabric as fabric. That's how I'm going to import it, and my alias is fabric. Now I can show you two different ways how you can use Semantic Link. What I'm going to do first is show you how to use Fabric, assuming you do not have any existing BI model in Power BI model that's already created. Okay. So what I'll do is first import some data. So this is some just random data, business data that I found on GitHub. which looks like as it comes up, you will see that it is, um, give it a second. Yeah, so you can see there is a region, country, item type, sales channel, and then some products, some cost and price associated with it, then the total cost and total profit. So a very typical business data set. And if you, there are many different ways we can analyze the data. Maybe your end goal is again to create a forecasting model on top of this, and then deploy this model so the business intelligence developer can use it in their reports ultimately. Now, as I import this to analyze this into using a semantic link, I'll first have to convert this into a Fabric data frame, which is nothing but I can just pass it as Fabric data frame. So I imported Fabric data frame class from Fabric, and then I passed the pandas data frame to it to convert that into a Fabric data frame. Fabric data frame, it supports the entire pretty much all the entire Pandas API, meaning I can use the same Pandas API that you are familiar with. So FDF is my Fabric data frame. So FDF and then columns, for example, and then I will get all the columns that I need. I can again, I can use units sold and select a single column. uh, Let me go here. Units sold. Uh, oh, I need to do the columns, sorry. So units sold, and which is what I'm going to do. And that I can use all of this to, same way what we can do with a Fabric data frame, right? So it works exactly the same way. Plus, on top of that, in a Fabric notebook, you can also use Data Wrangler, which is a feature who you can use to work with the semantic data frame or pandas data frame using UI. Meaning, I could go here and then if I wanted to not use Python and use a UI to work with my data frame. So just a tip there. Now, as I import this data in here, I'm new to this data, right? I don't know anything. Now, just based on just looking at these different columns, I know what this data means, right? So ship date, order date, it means something. Unit cost, unit price it means something. And why do I, if somebody tells me that, hey, you analyze this data, just based on the column names, I know what exactly I need to analyze, right? But that may not always be the case, which is where the semantic relationships really help. I can use the find dependencies method in Semantic Link to identify dependencies among these columns. So what I'm seeing here is order ID. There is no dependency on it. Whereas order date, there is a one-to-one relationship between these two, meaning for each order ID, there is an order date. For each order ID, there is a ship date, but for each order ID, there is a total revenue, total cost, and total profit, and all of three are grouped together, meaning there is some relationship among them, and which makes sense as well, right? Because the total cost, so we have total revenue, and revenue minus cost is a profit, right? So there is a relationship. Now we have not provided any other information to fabric to semantic link, but just based on how the data is, we are able to identify exactly how these different columns are related to each other. Similarly, item, unit price, and unit cost. So I know all these three different columns are maybe pertaining to a single product. Semantic link can really help you identify dependencies among all of these different columns, which is super helpful. I can go ahead and then plot this, drop duplicates like I showed you. And then I can also identify relationship among all of these different columns. So meaning if I plot uh, some relationships here, you will see that there is country, state, but the postal code and then state here, right? Which does not make sense because for each state and the city, there should be one unique postal code. But looks like there is some error in this data, and sure enough, we can see that there is one zip code, this zip code over here, which has two different cities assigned to that. So there is some error in the data that we will probably want to clean in here. Going ahead, what if so we looked at um, finding relationship among different columns. But what if I have different tables or different data sets? So in this case, I'll show you that I have these different tables here. I have date, fact, industry, and all of those. And I want to identify if there is a relationship among all of these different tables, which I can do that using semantic link. So what I'll do is I'll just read all of these tables, store them in a dictionary, and then plot the relationship among all these different tables that I've identified. And then what semantic link will do is it will scan the data. So it does it two different ways. So it will identify the column names and as well as it will scan the data and tell you how these different tables are related to each other. Meaning I have the fact table here, which has a BU key, and there is a BU table here, which has the BU key, right? So easy enough. So we know that the fact table, there is a one-to-many relationship between the fact table and the BU. Same thing with the fact and the customer. And how is this helpful to you? Well, as a data scientist, maybe you work with the data engineering team or you work with the business intelligence team, and the data has already been normalized for you. But because it has already been normalized, it's not in one single table. So you can easily use a semantic link to identify relationship among all of these different tables and figure out how exactly you need to denormalize it to create your data science application. But what about working with Power BI semantic models? So Power BI, this is a Power BI report based on the same data that let's say your a BI colleague has already created. And there is some KPIs here that are created, but now you've been asked that can we enrich this report using a data science? Maybe you create again a forecast, right? Now, the point that I raised earlier, should the data scientists at this point create their start from scratch, import all the data, figure out how to define sales, figure out how to define profit, and then recreate that semantic definition? Or shouldn't they be able to use the same definition that your BI colleague has already created and then use that as a starting point, right? And sure enough, that's what semantic link allows you to do. So what I will go and do here is I already have, let's see, I already have uh, I already have I can access this semantic model, the customer profitability sample, and then I know this particular semantic model has a measure called total revenue. So I can use total revenue, and then I want to aggregate it by year and the period, and that's how I can get this definition. I didn't have to again go and then define how exactly I want it. I want to use the same definition of revenue that the business intelligence developer has created for me. I can also scan all the tables that are available. So I can scan all the tables, for example, scan all the measures that are created within that same semantic models, and use that as my starting point. So this really allows you for the data scientist and the business intelligence developer to collaborate with each other. But then we can take it next step further. For example, and then create uh, uh, the and then we can create, for example, forecasting model on top of that. So, for example, if I go here, what I did was I used a theta model just for the sake of a demonstration from stats model, and then the same data that I imported from my semantic model. I created that, deployed that, those predictions, and now I can relay that back to my BI colleague who can take it over from them. So the whole point of doing all of this is we want to be able to use the exact same definitions, the semantic definitions that are used in the semantic model across the entire solution that is created for our organization. So I hope this was helpful to you on how you can use Semantic Link to break data silos in your organization. If you want to learn more about Semantic Link, go to aka.ms/senpai here, and you will see that Microsoft has a rich documentation on that, which really goes into what Semantic Link is and all the different features that are available within that. So thank you again, and I really appreciate you joining.